Hello everyone, welcome at Core Protocol Sync. We share updates from the Subspace team, what we've been working on last week and what we plan to do next week. And Ivan, do you want to share what's your progress?
Yeah, sure. But yeah, as I said earlier, on the previous meeting, I didn't do anything related to the core protocol itself. I can go over like the telemetry and pull requests there, if you want to.
I think that's more for the product side.
Yeah, that's
Okay.
that's what I had in mind also. Yeah. So yeah, also apart from that, I also was working mainly on the product side. I also was working on the Subspace SDK. Yeah, and generally like pushed some pull requests to the upstream of the telemetry. So yeah, that was all on my end.
Cool. But you still review a lot of pull requests. Thanks for that.
Yeah.
Okay, Shamil, turning to you then.
Sure. Last week, I mostly finished the design for the distributed storage network version 2, proposed an implementation plan, and started with the actual implementation. And let me show my screen to explain some details. So we mostly finalized our design for the DSN v2. We agreed on the network layers, on major workflows, and I proposed an implementation plan in several stages. Current goal to split it in 6 different, but not even stages for improved stability. At first, it would some cleanup. First stage would be some cleanup, just preparation. Then basic functionality, storage for the pieces and object mappings. After that, we will pause and implement some, add some metrics and establish some testing ground for the network. Moving on to the object cache, and then we will add archival storage for pieces and object mappings that we plan to use very rarely. And after that, we will test the system on some edge cases like high churn or some other issues. For the actual work on the implementation side, I started to clean up the code. I removed the obsolete relay node features, DSN archiving. I refactored DSN syncing feature and moved related code to a separate file to just leave it for now, and we probably heavily refactored more when we add actual syncing for the version 2. We moved away from our modification for cadem-layer algorithms. We restored cadem-layer double hashing for keys. And since we're not going to use SR25519 key pairs, we will probably switch to the upstream branch. We won't use our own cadem-layer branch, the P2P branch, in the future, which is a good news. And also, I plan to remove import blocks from the DSN feature, but I'm not sure. We are discussing it right now, and probably it will change. For this week, I plan to finish this PR and remove obsolete code, and started to implement proof of concept of the DSN v2. That's it.
About syncing from DSN, I can comment quickly on that. So when we have working DSN, the idea is that nodes will sync from that DSN instead of from other nodes, because nodes will not be archival anymore. And because of that, that mechanism that we've implemented, it will basically stay. We may change it. Instead of like downloading pieces, we'll download objects like blocks if we have object mappings for those. But the mechanism will still kind of be the same. We download the block, we import it, we download the next block, we import it, we like verify everything. So I don't think we need to delete that. Is what I'm
Okay,
getting.
I will add this feature then to our main plan, and then I won't remove it since we need it actually.
Yeah. like in the short term, we will not use it, but once everything works, that is like where we are heading.
So it's even past this archival storage stage. Will it be
It's
the last
probably
featuring?
past Gemini 3.
Oh, okay. So it's long term. Okay.
Yeah. I mean, it's midterm. It's not long term.
I would like it if we could achieve that by Gemini 3, but I think that's
Yeah.
a separate discussion we need to have.
Okay. If you have different priorities, let's just when we need to implement it.
Okay. Lucian, I saw you have submitted a few pull requests this week. Would you mind sharing that?
Yeah. Let me share my screen. Yeah, so during the last week, I have a few PRs. So the first one is like to merge the previous execution receipts, like submission, into the bundle. So we will no longer have the path for submit the execution receipts, and everything will be embedded into the bundle. So the will be basically two PRs. The part one are the part one is already reviewed by Vid. It would be great, and like another can have a look as well. The last piece during this like merge receipts will probably goes to this like another task, which is the fork handling. I have proposed the first part, which will be like integrates the primary blocks like fork choice into the secondary chain like block import, which means we'll like let the secondary like block literally follow the primary chains like fork choice. The second part of the fork handling is in the another branch. I will do some final tweaks like before sending the PR. Yes. Oh, okay. There's another thing is like we currently just disabled this like a full bundle gossip over the XNet, and will enable that after we migrate the full bundle into the compact bundle. Yeah. The compact bundle will just include the transaction hashes. Okay. Yeah.
That's probably because the primary chain still has full bundles, so it doesn't make sense to broadcast it twice, right? Is that correct?
It's like one is to make a few things simpler. Another thing is to save some bandwidth.
Okay. Any other questions about this? Okay. Daria, do you have anything to share about the implementation?
Well, about implementation, not, but about specifications, yes. And I mean, I have done maybe I could share what I imagine should be the DSN version 1 specification. So basically it describes that we have two node types, the main ones, then we have auxiliary nodes. It's including the architecture diagram. It's going to include the protocols that are needed. Here on top are going to be the custom protocols that we have implemented for it. And also it's going to briefly list the libp2p protocols that we're using and just link to their documentation without going into detail what those do. These, I'm not sure they already exist in V1, but I decided to add them as client interface functions, and I'm going to describe the 4 main workflows as I plan. How do you actually put the data to the DSN? How do you get the data from the DSN? and what do nodes do? But this is still very raw. Though I feel like I am a little bit confused still about what's the executor and farmer and what do they actually do and all of that. And when we say, like, the question, maybe the main question that I'm trying to ask is, when we say a node, we mean a farmer.
Remember I did that like glossary kind of page in Notion that explains what these things
Yeah,
are.
I think so.
It does explain the difference. Usually when we are talking about executor, the opposite to executor is the consensus node. The other name for it is primary secondary. And farmer is like a separate application altogether. So we will have like a farmer, consensus node, and executor node, like all joining DSN, and like doing different roles. So some will upload certain things, some will produce and offer for downloading those certain things.
Yeah. So what I wanted to do for this document is to briefly describe their roles in the DSN, but I don't feel right now like I'm capable of doing that because I don't really understand it well. So that's one issue. So I wrote here that executor nodes are referred to as nodes and farmers nodes are referred to as farmers, but not sure how clear is that either.
I don't know that we need to really have a notion of executors in the DSN. It's not strictly necessary for the DSN to work. Especially since it's going to change from V1 to V2. I don't know if it's really worth spending too much time on this for like a deprecated implementation.
Well, in V1, I don't think executors existed on the DSN level at all. So just like node and farmer, two entities. And even then, like node didn't really participate. Like there was no instance of the networking on the node. So you can probably just delete executor paragraph completely.
So if there is, I know it's not, does it exist yet? So when there is a client obligation and it would upload an object and include it into a transaction, the transaction goes to the farmer.
Transaction goes into the block. The block is then archived by the node, likely executor. And then farmers will later download those pieces from archived segments and they will plot them.
Okay, so
It's
still
not
need.
like we take object and give it to the farmer. No, farmer takes pieces, and there is a mechanism how you reconstruct that. I feel like it would be useful for you to be on the next sync about DSN when we discuss these things, because we were going into some details about how that is organized.
Yeah, maybe that would be useful.
So in V1, there is really no decoupled execution. It's never implemented. So we're kind of trying to describe things that don't actually exist or were never implemented. So I think we're kind of wasting our time here going into this much detail, trying to make it perfect here. I think what you've done is probably good enough for this level that you've gone in for V1, Daria, and we could probably review it. And then with a lot of these, like, you know, these questions that you have are trying to make it like perfect. I think the time might be better spent on V2. Because a lot of this stuff was never actually implemented in V1. We were just trying to get it caught up to the implementation, not the design in the white paper.
Okay. Well, then I will finish up this, well, basically what I understood the workflows are, and then I will share it probably later today or early tomorrow with you to look at it. Well, in the like research chat or engineering chat.
Okay, thanks, Daria. Let me share my screen. I think you should be able to see this. One new thing from last week is updated dashboard that we have in GitHub. I basically changed, I closed Gemini 2 milestone and created Gemini 3A and then Beyond Gemini. And I tried to aggregate the tickets that Jeremiah put as drafts into something that can be implemented. And also there was a ticket from Lu Cheng that we put here. So basically, when we are working on something related to Gemini 3, two things are required. Add it to the milestone and add it to the project. So it is displayed in this board, and then move it across as we change status. And there are also priorities here. So there are a few critical things that we had to do. There was one to change the piece size on the protocol level from 4 kilobytes to something bigger. And since we crossed kind of threshold in terms of the archiving implementation, basically when we have encoding of bytes in scale codec, depending on how many bytes we have, the prefix length is different number of bytes. It can be 1 byte, 2 bytes, 4 bytes. So a lot of tests had to change because of that, and a lot of nuances were uncovered. We have changed the Blake2 function. We have, this is something the chain was working on. And we were also changing the commitment scheme. The thing I'm working on right now is to change the plotting mechanism. Previously, we were plotting plots. Every plot contained number of pieces. Then we created commitment databases for those and so on. That will change into basically plotting sectors. Every plot will have one sector. We'll see if we unified naming so that sector doesn't exist anymore. But for now, that will be the implementation. And I'm just trying to make a very basic implementation where we don't have proof of space. We don't have any encoding, just like an XOR function. The very basic scaffolding for the whole protocol, and then we can replace those pieces with something more meaningful. Once that is done, the next critical thing is to update and extend benches. We have quite a few of them. We just need to turn them into something like this, where we can measure time to archive one segment or plot one sector and so on. And then as we progress through different stages, we can monitor and observe how these characteristics change of our protocol. And after that, there will be more lower priority tickets where we can do some of the things potentially in parallel. But this is what we have for now in terms of the board. On GitHub, I was showing you the in progress stuff last week, I believe. So there was a pull request about introduction of KZG that was merged. Just introduces a few primitives that are relatively easy to use. We just have this new module. And then when you go here, we have this abstraction called KZG. We can generate either random public parameters, or we can use something that was created before. And then we can commit, or we can create a polynomial from some data. Then we can commit to it to get basically the root in terms of Merkle tree naming. And then we can create a witness for a piece of data of that polynomial by index. And then with polynomial commitment and with the witness and some other parameters, we can verify whether that was done correctly. So that's the basic API that we have in here. And with that API, we can create the change in the archiving. So previously we had the Merkle tree root, which was 32 bytes. And then we have 48 bytes witnesses. I renamed this constant for Merkle tree num leaves to pieces in segment. That's clearer, and we don't have Merkle trees anymore. Otherwise, it's basically the same stuff. Just the size of this thing has changed. So a lot of tests had to be updated, and Merkle tree module is deleted. Otherwise, it's just the type alias has changed from hash to commitment. This is mostly what I was showing before. I hope it makes sense. The next change was to update the piece size. And again, because the archiving deals with these offsets everywhere, that again shifted many of the tests. So archiver changes are not very big. That's quite trivial. However, I had to work on archiving tests a little bit to make them more robust against future changes if we have to increase it like once again. And also, I have added some additional documentation and I believe some test cases to handle. So basically, these tests are like test edge cases, and it is possible to change implementation such that this test will work after some changes, but it will no longer be on that boundary that tests the edge case. So I've added this test case to ensure that we are actually on the boundary. So one should succeed and the other should fail. Like the boundary is between those two. Otherwise, they will both fail or both succeed, and that means that the implementation doesn't match the expected behavior. So I had to basically like revisit everything that was written before and like recall what it does. So I left some additional documentation for Prosperity in case someone needs to modify it in the future. Yeah, on the reconstruction side, the same, like offsets has changed because we have different piece size. Otherwise, it works, except it didn't. I just today noticed that there was actually a small problem on the RPC level. The segment was too big to fit into the message for the JSON RPC. So we had to increase the request body size from 10 to 20 megabytes because the response was about 16 megabytes after these changes. Otherwise, we have quite a bit different protocol in terms of the piece sizes and crypto, but it still produces blocks if you build the dev chain. So that's good.
Is there a question on that? So if we have 32 kilobyte pieces and we have, is it 256 in a segment still with the erasure coded? So we're at 8 megabyte segments now?
I think so.
Okay. Awesome.
Yeah, but when we serialize it to JSON, like it's hacked, so it's double. So that's why 16.
So over the wire, or at least over the RPC, it's double.
Yeah.
Okay.
And there was another pull request today towards the goal of this changing of the plotting mechanism. Basically, in the consensus v2, instead of plotting segments as they are produced and overriding the history, we will create sectors which expire at a later data depending on some parameters. And like they will expire at different time for different plots. And for that, we basically, when it expires, we need to pull based on some algorithm, certain number of pieces. And we don't have DSN yet, so we need to get them from somewhere. And we don't really want to like store information about what was archived at which height and then reconstruct that thing on the fly. So what I decided to do is to just add basic piece cache on the node. We can use auxiliary storage for that. So there is a basic trait which has add pieces and get piece methods. And there is auxiliary piece cache implementation for that. On the node side, there is a to-do to add support for limiting this, because this is something we can use later for DSN. When we need to store like last n pieces that were produced, we can cache them here. For now, it just stores everything, so farmer can refer to this at a later date anytime. And I have wired that through the service. It is created in the service, this instance. We have a worker which basically listens for the archived segments, and it will try to add all of those pieces produced into the cache. And on the RPC level, we send it through the RPC level, and we have the method for getting those through RPC, so farmer can use that in the meantime before we have the full DSN implementation.
Do we have a Genesis segment with Genesis pieces as well?
Yeah, it's available as well.
Cool.
Yeah, I think that's it on what has been finished and in review. This week I will continue towards this goal, to have some basic implementation of the new plotting mechanism, and I'll continue marking the things that were implemented in this specification. I have marked all of the KZG stuff in green. Daria updated the API to what it actually is in implementation. So we are in full sync there. Yeah, we'll update about the progress next week. Any questions about any of this? Or maybe something else we need to discuss? All right. Thanks everyone for great work, and thanks everyone on YouTube for watching, and we'll see you next week.